Hello, Algebra 2 students. This is the second part of Chapter 4, where we're taking a practice test on sections 4.6, 4.7, and 4.8. Just 3 sections. Important for you to remember, we have to know b over 2 squared is how we complete the square. That's how we come up with the number that will make a perfect square trinomial. That's why it's called completing the square. And we have to know x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And then we have to know that the discriminant is just this part of the quadratic formula. So those are the formulas that we absolutely need to know, along with the new information that we learned about I, that the square root of negative 1 is I, and that I squared is negative 1. I keep trying to put an extra little dot on that. There we go. So those are the biggies. Now, the objective today is to rock out the test, and if we can do a really good job on the practice test, hopefully we will build up our positive thinking, and we'll do fantastic. That's what we want to do. So the first problems here say solve by using square roots. This was how we first started section 4.6. And we said, well, since they don't have an x term, a middle term, these can just be solved. So I'm going to go ahead and add 81 to both sides. And then we say, well, how do we undo squaring something? We take the square root. And whenever we physically write that square root symbol down, when you find yourself doing that, you have to put the plus or minus in front of it. So this will be plus and minus 9. And of course you could put the 9 and the negative 9 back in there and make sure it works. So that's an added little bonus. Now, I'd like you to pause the video and try to do number 2 on your own. So number 2 on your own, pause the video. With number 2, we would subtract 72 from both sides. And then we would divide both sides by 4, because again, we're trying to isolate the variable, which means get the variable all by itself. But we have negative 72 divided by 4, which is negative 18. So now when I take the square root, I realize, ooh, this is going to have some imaginaries in it. I've got that plus or minus, but I need the square root of negative 1. And then you think about 18, perfect square that goes into 18, biggest one is a 9, and it goes in twice. And then we kind of translate that back into numbers, which would be plus or minus I, 3 and the square root of 2, and then write it so it looks like it makes sense. Plus or minus 3i square roots of 2, or 3 square roots of 2 with the I all the way in the back. So this is checkable. You have to remember that when we square I, we get I squared, but we can take both of those and put them back up there and square them, and we will get an answer that works. It'll give us a 0 on the other side. So those were solving using square roots. The next one is just what value completes the square. Again, if you want to pause for a second and figure that out yourself, do so. We have to use our little formula, b divided by 2 squared. So I check and make sure it's ax squared plus bx, which it is, and that means my b is negative 12. So it'll be negative 12 divided by 2 squared. We know that the order of operations tells us we have to do what's in the parentheses first. So negative 6 squared, which is negative 6 times negative 6, which is 36. And if you decide to put this in your calculator, by golly, you better use parentheses or the calculator's not going to give you the right answer, because we need all of negative 6 to be squared. So for this test, it's going to be really important, if you're using the calculator, that you are using parentheses for anything that you are plugging in to that calculator, anything you are evaluating. All right, now 4 says, well, let's try and take this to completion, which would be, let's solve by completing the square. We just figured out what value for C would give us a perfect square, but these are solve it by completing the square. So I'm going to do B first, and I know that feels weird, but I want to do B with you and then have you go back and try A on your own. So I'm looking at B, and the good news is it has a 0 on one side. The bad news is there's a negative in front of the squared. We can't have that. Remember, to complete the square, if there's anything in front of our x squared term, we have to divide by it. Now, you could move the 26 over first and then divide by -1. That's totally fine. But we'll get the same answer if we just go ahead and divide by that -1 right away. And of course, that changes all the signs. And then we'd go ahead and move the 26 over because it's not a perfect square. And now we use the skills we just used in the previous problem up there of b over 2 squared to figure out, well, what number will make this work? So b is 14. 14 divided by 2 is 7, and 7 squared is 49. But what we add to one side to get our perfect square trinomial, we also have to add to the other. So we get 26 plus 49, which just happens to be 75. And on the left-hand side, we just made a perfect square trinomial. So we think, well, what did we square? Well, obviously, x will have to be squared to get x squared. And then what did we just square to get 49? We come back up here, a 7. And since our middle term is positive, it would be a plus. And now we put the skills from the first two problems and the third problem together, and we take the square root of both sides. Certainly, we will remember our little plus or minus. And then 75, we think about our perfect squares and work backwards. 64 won't go in, 49 won't go in, 36 won't go in. Oh, 25 goes into 75 perfectly 3 times. And then we would simplify that to plus or minus 5 square roots of 3. And last but not least, we'll subtract 7 from both sides, and x will equal -7 plus or minus 5 square roots of 3. And we've got it. So it's solved by completing the square. Now this one, like I said, I did this first because this one was a little tougher than A because we had to divide the negative out first before we could complete the square. But give A a try, hit the pause button, and then start it back up again when you feel you have it, so you can check your answer. With A, I don't have to divide by anything. There's already 1 in front of x squared. So now my focus is on, hey, this 7 is not a perfect square. And next up would be, well, what number is a perfect square that would give us a perfect square trinomial? Well, let's see. Our b value is 16. And we have to divide it by 2 and then square it. That's 8 squared, which is 64. And what we do to one side, we have to do to the other. So we'd have to add 64 plus 7, which is 71. And then we recognize that we just made a perfect square trinomial on the left-hand side, and that is x plus 8, because we just said we had to square 8 to get 64. Then we take the square root of both sides, and we check. Square root is 71. Yuck. All right, so next smallest perfect square would be 64. Nope, that won't divide into it. Then we'd have 49. Nope, that's not going to work. Then we'd try 36. Nope. 25. 16. No. 9. No. 4. No. None of them. So that's as simplified as that's going to get. We just still have that last step of subtracting 8 from both sides. So negative 8 plus or minus the square root of 71. So that had fewer steps. We didn't have a radical that we could simplify as we went through. Alrighty, number 5, write each in vertex form. Well, this is doing the exact same thing we just did in problem number 4, but making sure that we keep that y involved, because what we have to do is make it look like vertex form. So again, I want to do the one that's a little bit tougher and then give you a chance to try the other one on your own. So for B, the reason that's a little bit tougher, there's a 2 in front of that. So a lot of people prefer adding the 4 first and then dividing by the 2. So we'll go that way. Now I have to figure out what will complete the square. Well, my b value is in front of my x. So I have to take the 4, divide it by 2, and square it. And that's going to be 4. So this is now a perfect square trinomial. We just said we had to square 2, so it's x plus 2, the quantity squared. On the left-hand side, it's up to you. You could say, you know what, I'm going to leave that for one step, then I'll subtract the 4, and then I'll start moving the other 2 and the other 4 over. But it does go a little faster and easier if you just use a common denominator here and say y plus 4 over 2, and then how does a person write 4 as something over 2? Well, right now we have 4 over 1. And we'd multiply the numerator and the denominator by 2. So that would give us 8 halves. Now we can go ahead and add those two fractions together. That's going to be y plus 12 over 2 equals the quantity x plus 2 squared. I'll move this down a little bit. And then we can start moving everything over. So we could multiply both sides by 2. Y plus 12 equals 2 times the quantity x plus 2 squared. You can't put the 2 inside the parentheses. The 2 is not something squared. The stuff that's in the parentheses is squared. They're not the same type of terms. We cannot put it in there. So it stays out in front as an a value. Then we subtract 12 from both sides. And 12 is not something squared either. So we just move it to the back. Now, if there were a follow-up question for this one, it would probably say something like, where's your vertex? And where's your axis of symmetry? Because that's what we used vertex form for. Just remember that the x is always the opposite of what it appears to be. So instead of a plus 2, it's a minus 2. And then we have the k value of negative 12 in the back. And our axis of symmetry will always be a vertical line, so it's always going to be x equals, and whatever x equals is the x coordinate of the vertex. So that'll be x equals negative 2. So that puts a lot of our objectives together from 4-6, where we're trying to say, let's use this to do something that in the past was a little bit more of a struggle because it was in standard form. Speaking of standard form, there's A. So if you think you're ready, hit the pause button. Try that one on your own. Remember, don't lose the y. Keep the y in it all the way through. And then you can hit play when you're ready. Alrighty, there is no number in front of the squared this time. So I can go to moving that 11 over right away. And we're already to the step of needing b over 2 squared. So we will need 8 divided by 2 squared, which is 4 squared, which is 16. So we will have to add 16 to both sides. and we get y plus 27. Notice we didn't have a fraction over there, worked out really nice. And then we think, well, what did we square over here? We squared a 4. And now all I have to do is get y by itself. So I'll subtract 27 from both sides. Again, that's not a squared anything, so it can't go in the parentheses. And then, like I said, if there were a follow-up question, it would say, what's the vertex? What's the axis of symmetry? And our vertex for this one would be -4, -27. And our axis of symmetry, always vertical, x equals, and what does x equal? -4, wherever our vertex's x coordinate is. Now, all of the problems that I just went through are problems from section 4.6. So I'm going to hold off until Monday to talk to you about all the wonderful things that we did in 4.7 and 4.8 to finish this up. And I know we only went through 5 of these, but I have a pretty good idea that you're not going to struggle a lot with the quadratic formula piece and the discriminant piece, and that will leave us with more of these to do together on Monday, which I think will be much more effective for your review. So this is the assignment that you need to do, the day 1 review. Pages 237 to 238, 35, 46, 49, and 73. That's 4 little problems. And then page 245, number 37 and 38. And then, like it says for number 38, if when you do the discriminant you find that it does have an answer or 2 answers, then please find it. Find that answer. So that is your homework. Please do this on Friday. Don't wait until Sunday night at 11 p.m. Remember, we have a test coming up next Tuesday. It's really important. Also remember that some of you haven't been reading your Schoology comments. If you didn't show work when we went through the completing the square section and the quadratic formula section, well, then you got a comment that said you need to fix those and you need to submit those again. So, teeny little assignment, gives you time to catch up on all the other ones and get those in so that you can have a fantastic score on Tuesday. And if you don't have a fantastic score because you'll have all your homework in, you'll be eligible for the retake. Have a great weekend, everybody.